In this video I just want to introduce some of the basic notation regarding arrays, matrices and vectors. What we have here is array A, which has 3 rows and 4 columns. Notice that A2, 3 refers to the cell in row 2, column 3, and A3, 2 refers to the cell in row 3, column 2. So when I want to generate a horizontal or a row vector, I simply say variable 3 is assigned to, and then I put in square brackets the numbers 2, 4, 6, 8 and 10. So I have a vector that has 5 columns and 1 row. It's also an array, but because it's only one dimensional, it's a vector, and in this case a row vector. In this case I'm saying variable 5 is assigned to 7, semicolon 5, semicolon 3. Every time you get the semicolon it means jump to the next row. So this generates a column vector which has 1 column and 3 rows with the values 7, 5 and 3. When I'm declaring variable 6, I'm saying 1, 2, 3, semicolon, 4, 5, 6, semicolon, etc. Remember from the previous slide, the semicolon means jump to the next row. So this generates a matrix because it's two-dimensional with 4 rows and 3 columns. Now we don't call it a vector anymore. It's still an array, but in this case it's called a matrix. In the top left-hand corner we declare variable 10 as 2, 4, semicolon, 6, 8. Which simply creates a matrix with 2 rows and 2 columns. Then in the top right hand corner we say variable 10 round brackets 2, 2 close round brackets is 4. When we're using the round brackets it refers to a specific cell in variable 10. So what we're doing is row 2 column 2 is changed to the value 4. So it's not 8 anymore, it's now 4. Then in the bottom right hand corner we do something interesting. We say variable 10 row 3 column 4. Now clearly up to now variable 10 did not have a row 3 or a column 4. What it then simply does, it puts 4 in row 3 column 4, and all the extra cells that were added to the matrix are initialized to 0. So variable 10 now becomes bigger. The 4 goes into row 3 column 4 and all the additional cells are initialized to 0.